So in this video, we are going to learn about reflections on a coordinate plane. So a reflection is another kind of transformation that flips a figure over a line of reflection. Kind of like a mirror, in order to create a mirror image. Each reflected point of the figure should be the same distance from the line of reflection. So reflection is considered not a rigid transformation because it actually changes the image. Like imagine if we've got this guy, his name's Bob, and here he is waving his hand. And let's see, that's his right? No, that's his left hand. So he's waving his left hand because he doesn't have a right arm. He lost his right arm in the war or something. If we take a mirror image, if we flip the image, we take Google and we actually flip the image, what would it look like? Well, it'd look like this. It'd be the same guy, except, look, it looks like his right arm. Sorry. It looks like he's waving his right arm, right? Because his left arm is missing. So if you looked at our our new picture, if I manipulated this picture and you're like, oh yeah, that's Bob and he's got a missing left arm, you'd be wrong because it's actually his right arm is missing. So if you looked at the original image, you saw the person, you'd be like, oh, his right arm's missing, not his left one. So a reflection is not considered a rigid transformation. It actually changes the transformation. You know, imagine if you had a lazy eye or like a mole on the left side of your face. If you flip the image around, if you took a photo and you flip the image, it'd look like the mole is on the other side of your face. Anyways, they want us to highlight and identify the line of reflection in each example. So let's say this is our original. Which line is our new image reflected over? Well, it is reflected over this axis, the x-axis in this case. And if I take a look at this, let's say this is the original image and this is our new one, where is it being reflected off of? It's not being reflected off that line because you'd assume this be a face right there, there'd be a face down there. It's being reflected off this line right here, and that line is the y-axis. So we can reflect an image off the left x-axis or a y-axis. Now, you can reflect it other ways too, but let's not focus on that. All right, so number one, reflect the figure shown over the y-axis. Reflect the figure shown over the y-axis. Record the coordinates of the pre-image and image. So the y-axis is this axis right here. And they want us to record the coordinate points, each point, so W, X, and Y. And let's take a look. W is at 2 and 6. X is at 7 and 4. And Y is at 2 and 2. Now, if I reflect it off this line, what I'm going to do is, you see how this point right here is 2 units to the right? I'm going to take W and I'm going to put it 2 units to the left. So it'll be right over there. That'd be W prime. W prime. So, you know, what was like 2 units to the right, I'm going to move it 2 units to the left. Let's look at X. X is 7 units to the right. Well, I'm going to go 7 units to the left, so right over here. And that's going to be X prime. Y over here, 2 units to the right. I'm going to move it 2 units to the left from that line. And that's going to be Y prime. And here's my new image. So let's do W prime, X prime, Y prime. What do I notice about the ordered pairs there? W is at -2, 6. X is at -7 and 4. And Y is at -2, 2. If I look at the ordered pairs, describe any patterns found in the ordered pairs. So what patterns do you see? Let's look at the X. The X goes from 2 to -2, y 6 to 6. 7, negative 7, sorry, 7, 4, negative 7, 4, 2, 2, negative 2, 2. What happened? Is there any, they're almost the same, except the x, like 2, then negative 2. 7, negative 7, 2, negative 2. Whereas the y's stay the same. 6, 6, 4, 4, 2, 2. So x's value changes signs. And what I mean by sign is the plus negative sign. Y value stays the same. So the y value stays the same. How can we represent this algebraically? Well, we would write this as, if we have x comma y, what are we doing to the x? Well, we are changing the sign. How do we represent that? With a minus sign, with a negative. So basically the idea is if it's positive, it turns negative. If it's negative, you change it to a positive. So it flips the sign. Let's look at number 2. Reflect the figure shown over the x-axis at the time. Not the y-axis, but the x-axis, which is the this axis right here. Record the coordinates of the pre-image and the image, so D, E, and F. So D, E, and F. So D is at 2 and negative 2. E is at 7 and negative 7. And F is at 2 and negative 7. So if I want to reflect this, let's start with the D. It's like reflecting over this line. I go 2 down, well then I'm going to go 2 up. And that's going to be D prime. Let's do E next. Sorry. E, go 7, down 7. So in this case, I'm going to go up 7. That's E prime. And F to the right, 7 down. So to the right, 7 up. F prime. So now I have my reflected image. So let's look at D prime. 2 and 2. Oops. Darn you. E, 7 and 7. F, 2 and 7. Do we see any patterns? X, 2 to negative 2, 2, 2. 7, negative 7 turns into 7, 7. 2, negative 7 turns into 2, positive 7. What do we notice? Well, the x's seem to stay the same. 2, 2, 7, 7, 2, 2. The y's, negative 2, positive 2, negative 7, positive 7, negative 7, positive 7. The y's seem to have flipped their signs. So x value, same. Y value changes signs. And what we mean by sign is the plus minus. It goes from positive to negative or negative to positive. How can we represent this algebraically? Well, x stays the same, but y, to flip the sign, you just put the minus sign. So when it's positive, it turns negative. If it's negative, it's like negative, negative, which means it turns positive. All right, let's take a look at some more examples. Reflect triangle PQR over the y-axis. The y-axis is this axis right here. Then describe what happened to each of the coordinates. Okay, so PQR. Let's do the R first. R is 2 to the left, so I'm going to put it 2 to the right, and that's going to be R prime. P is 7 to the left, so I'm going to move it 7 to the right. And then Q is 5 to the left, so I'm going to move it 5 to the right. It's going to be Q prime. Is that 5? It is 5. All right. So what happens to each of the coordinates? Well, looks like the y values stay the same, all right? Still 2. So PQR. P is -7, 2. Q is -5, 7. And R is going to be -2, 2. And what happens to P prime or Q prime or R prime? P prime, when we reflect it over the y-axis, the y's stay the same, but the x flips. So P prime is right 7 up 2. So 7, 2. Looks like the x flips, right? So -5 should turn into +5, 7. And then -2 turns to +2. And the y stays the same. All right, they want us to reflect our new P prime, Q prime, R prime over the x-axis, and then describe what happened to each of the coordinates. Okay, so now they want us to reflect it over this axis right here. So let's do it in a different color. So P, if I go 2 up, whoops. I want to go 2 down. So that's P, they call it double prime. Q is up there, so 5 up 7. I'm going to go down 7. Q double prime. And then R is 2 to the right, 2 up, so I'm going to go down 2. R double prime. That's a bad. So what happened to each of the coordinates? Well, my P prime was 7, 2. My Q prime was 5, 7. And my R prime was 2, 2. What happens to my new ones? P double prime, Q double prime, and R double prime. This is basically 2 apostrophes. Well, P double prime goes from 7, 2 to 7, -2. So if you look at the pattern, 7, 7, oh, the x stays the same, the y just flip sign. So do the same thing, 5, 7, except flip the sign of the y. 2, 2, except flip the sign of the y. All right, let's answer the next question. Bella thinks that the transformation below represents a translation. Is she correct? Why or why not? Well, let's see. H, A, B, C, F, G, H, I, J. So a translation means we just move it. Everything still stays the same. We should still have G, H, I, J, but we don't. It looks like it's flipped like a mirror image. So it starts off with J, I, H, G. So is she correct? No. The points are flipped. Vertices or points are flipped or changed. Use the chart to compare and contrast translations and reflections. What do they have in common and what do they have that's similar? What do the translations and reflections have in common? Images are still congruent. Congruent, meaning same shape, same size and shape. What do they have in different? Well, translation. With a translation, orientation and vertices stay the same. Stay same. With a reflection, orientation is flipped. All right, let's use what we learned to show where given the following points would be after the given reflection. So x-axis. Remember, when it changes over the x-axis, the x-axis, so this axis right here, it means the y gets flipped. And when we flip it over the y-axis, reflect over the y-axis, the x changes. So reflected off the x-axis, that means the y is going to change. So 6, 8, y changes, that turns to 6, negative 8. Negative 5, 1 turns into negative 5, negative 1, because x stays the same, y changes. Let's rewrite 10, negative 9. X stays the same, y turns, flips the sign, so it turns to 10, positive 9. Negative 4, negative 11. X stays the same, y changes, flips the sign. And then 7 and 12. X stays the same, y changes sign, so that turns it to negative 12. Let's take a look at reflected over the y-axis. So let's say we had 6, 8. Let me rewrite all these points. Negative 5, 1. Let's do 10, negative 9. Negative 4, negative 11. And 7 and 12. So when we reflect it over the y-axis, the y stays the same, but the x changes. So A, negative 6 turns to negative 6, and 8 stays the same. Negative 5 turns to positive 5, and y stays the same. 10 turns to negative 10, y stays the same. Negative 4 turns to positive 4, y stays the same. And 7 turns to negative 7, y stays the same. So summarize what happens to the coordinates in a figure when the following occur. Reflection over x-axis, x stays same. Y changes, right? When you flip it over the y-axis, y stays the same, x changes, right? Yep. And let's, and reflection over the y-axis, that means y stays same. And x changes signs. Takes the opposite sign. So go ahead and take a look at some problems, see if you try them on your own. Good luck.